بسم الله الرحمن الرحيم. Today I will talk about it from the first topic in IGCSE syllabus, هو particulate nature of matter, and this is the first lecture or the first period about particulate nature of matter. This is lesson number 1. I will start from the first. We say everything is made up of particles, and matter, as you know, can be a solid, liquid, or a gas. Solid, liquid, or a gas state. So, we have 3 types of matter. 3 types of particles make up most matter. Here I have atom, molecule, and ion. Atom, molecules, and ion. And here I have Cambridge definitions. I have Cambridge definition, that means these are the definitions you're supposed to memorize and understand to write in your exam. The first one, atom, is the smallest particles cannot be broken down. The smallest particles cannot be broken down. Example, sodium atom, lithium atom, oxygen atom, or whatever. Atom is the smallest particles cannot be broken down. Here, molecules is a particles of 2 or more atoms joined together. This means what? This means if I have Cl alone, so it's Cl atom. But if you have Cl2, you see a particles of 2 or more atoms joined together, so it is molecule. If I write here O alone, oxygen alone, so it will be atom. If it was O2, so it's molecule. Why molecule? Because it consists of 2 atoms joined together. Sometimes maybe like ozone, or 3. Atom or ion is atom or molecule is molecule. Why molecule? Because it consists of 3 atoms joined together. 3 atoms joined together. So in general, when I need to talk about these particles, I will start with atom, then molecule. Ion. What is the meaning of ion? Ion is an atom carries an electrical charge. What does it mean? If you have in A alone, okay, so it's atom. In A alone, so it's atom. But if it was in A positive, so it will be ion. If you have Cl, chlorine alone is an atom. Cl2, it's not working, I think. I will say by my mouth, but listen to me carefully. Cl, chlorine alone, atom. Cl2, molecule. Cl, negative. This means ion. How do you know this ion? Because you said an ion is an atom, carries an electrical charge. So, the 3 particles I need for you to know: atom, molecule, and ion. Atom, molecule, and ion. Here, we need to know about Brownian motion. Okay. Thank you, Mr. Arif. I will give it again. When I talk about atom, please to see Cl. It's clear, I think now. Cl, so it's atom. Cl2, so it's molecule. But Cl negative, so will be ion. An atom carries an electrical charge. This is an electrical charge. If you have in A, so it will be atom. If I have in A positive, that means ion, because it carries electrical charge. Critical charge. بمعنى maybe you have a question which one of the following is an ion? Cl, Cl2 or Cl negative? Which one is ion? Cl, Cl2 or Cl negative? No, the ion is Cl negative because the ion must carry electrical charge. And the electrical charge may be positive, may be negative. Brownian motion. The simplest definition for Brownian motion is the irregular random motion of tiny particles suspended in liquid or gas. If this is a tiny particles, and these particles move from here to there, then down, then like that, then like that, this is called Brownian motion. A movement of tiny particles. But this motion, regular or irregular? No. The Brownian motion is the irregular random motion of tiny particles suspended in a liquid or gas. Here, if you have particles move in this direction, then here, then down, then go, here, random motion. This is a Brownian motion. This is the definition of a Brownian motion. Any movement of tiny particles in different direction. But this motion, regular or irregular random motion. This is Brownian motion. Right. The Brownian motion is caused by what? Why we have Brownian motion in the nature? But Brownian motion in solid, in liquid and in gas. What is the reason of a Brownian motion? Give me the reason for Brownian motion. By the random hitting of visible particles by smaller particles of the liquid or gas. They are suspended in which cannot be seen. What does it mean? If here I have a small particles, okay, affected by random hitting. This small one hit him, and this hit him. This hit him in this direction. There is random hitting between particles. By the random hitting of visible particles by smaller particles. You cannot see these particles by your eye. Of the liquid or gas, they are suspended in which cannot be seen. You're supposed to know what is the definition of a Brownian motion. Is to see. This is the definition of a Brownian motion. Why we have Brownian motion? By the random hitting of visible particles. These visible particles, you can see it. By smaller particles of the liquid, and you have visible particles hit by smaller particles. Right. Evidence of a Brownian motion. What are the evidence of a Brownian motion? What are the evidence of a Brownian motion? Brownian motion. Random motion of dust or smoke particles in the air. Random motion of dust or smoke particles in the air. Sometimes you can see smoke inside the air move. Maybe the smoke of cigarettes. Maybe of factories. Okay? Maybe dust. You can see dust move. This is one evidence of Brownian motion. The random movement of tiny particles of graphite suspended in water. You know graphite? Okay? Graphite is black. Bring a piece of graphite and try to break it to small pieces and put these pieces inside the water. You will see Brownian motion. You will see Brownian motion. Okay? So, the evidence here I have for Brownian motion. Number one, random motion of dust or smoke particles in the air. Number two, the random movement of tiny particles of graphite suspended in water. Imagine this movement, this blue movement represents a random motion of graphite inside water. Look, sometimes over here, go there, random motion. What you can see here, this is the random motion of graphite suspended in water. Suspended in water. The evidence of Brownian motion, random motion of dust or smoke particles in the air, random movement of tiny particles of graphite. Now we have new concept, new definition, new word. Diffusion. Diffusion. What does it mean? Diffusion is the random movement of different particles. So they get mixed up. Okay? If, for example, I need to say something, I don't know. I will bring something now. So for you, it's working, the water, yes. We have a water here, okay? We have a water here. If I put drops of ink inside water, what would happen? What do you think? If I have, but it's not ink. If I have ink, I'm supposed to bring it by alphabet. If I put here drops of any color, what do you think? The color will spread to the whole liquid. Okay? But diffusion is a random movement of different particles, so they get mixed up. Diffusion occurs in gases and liquid. Why? Because the molecules are constantly moving. The molecules in motion, in direct motion. This to see here. I should bring this card, but I forget. We have it here now. But at least to see this picture, it will show inshallah for you. Example: place a crystal of purple potassium magnate in a beaker of water. This is a beaker of water. If I put here a beaker of potassium magnate, the color spreads through the water. Why? Because the particles leave the solid crystals. Because the particles leave solid crystals. Just put here one piece of solid potassium manganate, so the color will spread through the whole liquid. This is example of diffusion. So if I have a question, I will give you this picture and I will say this picture represents diffusion or Brownian motion. Brownian motion. No, it's wrong. It represents diffusion process. Diffusion process. Example number 2. Example number 1 for diffusion process. Example number 1 for diffusion process. This example. Example number 2. When I talk about this example, about it for more than 6 years in IUCSE exam, we have the question. We have the same idea. In 2017, in 2017, in 2004, in 2010. We have this question exactly or the same idea, What we have here, we need to understand. Example 2. Place an open gas jar. This is an open gas jar of air upside. I will show you. Wait. I have here 2 jars. Place an open gas jar of air upside down on an open gas jar containing a few drops of red-brown bromine. This means here imagine I have gas jar. Inside this gas jar I have bromine. I will put another one empty like this. This means down I have brown color. This is a brown color. What happened? The color spreads upward because particles of bromine vapor mixed among the gas particles. Look, at the first down we have down here brown color. After a few minutes I will see the whole area filled with the color of bromine. Here at the first, before, down I have bromine vapor. Bromine vapor with which color? Which color this? Which color? Red brown color. After a few minutes, what you have? Look. After spread. The whole area filled with bromine vapor because of diffusion. This is the second example. But from here, which area have more concentration? The particles move from area of high concentration to area of low concentration. So here, just to make a quick revision about this, I start with in particles, and I have the matter, can be solid, liquid, or gas. And we have 3 types of particles make up most matter: atom, molecule, and ion. When the atom, the smallest particles cannot be broken down. But for example, say Cl, chlorine atom, molecule is a particles of 2 or more than 2. Is a particles of 2 or more atoms joined together. The ion is an atom, carries an electrical charge. يعني Cl alone is an atom. Cl2, I have here 2 molecules joined together, so this is molecule. Sorry, I have 2 atoms joined together, so this is molecule. Finally, if I have Cl negative, this means ion. And we will know after that what is the difference between negative charge at the top of atom or positive charge at the top of atom. After that. Now, what we will find in the ion, an atom carries an electrical charge. Electrical charge may be negative, like chlorine, and may be positive, like sodium. So this is ion. Why ion? Because it carries electrical charge. Okay? After that, I said we have something is called Brownian motion. And we said Brownian motion, oh my god. Brownian motion is random motion of particles. Down, up, right, left, the center. Brownian motion. The right, the left, up, down, random motion. Is the irregular random motion of tiny particles suspended where? suspended in a liquid or a gas. This picture represents what? Brownian motion. Brownian motion. And Brownian motion is caused by what? In the Brownian motion, you have visible particles. You can see it by your eye. You can see it move. Why it move? Because small particles, you cannot see it hit it from each side. Look to see. Here we have visible particle hit by small particles. Small particles. By the random hitting of visible particles by smaller particles of the liquid, and smaller particles hit these particles of the liquid or gas, they are suspended in which cannot be seen. You cannot see these small particles which hit the particles there. Okay? After that, I said, what are the evidences of Brownian motion? The evidence of Brownian motion. Yeah, mister, you said we have in nature something is called Brownian motion. Give me evidence. What is the evidence? Okay. The evidence, number one, a random motion of dust or small particles in the air, like this, you can see. Sometimes in your home, you can see a small hole in the wall. You can see the light inside your home. Give you like this picture, or some smoke, or some dust inside your home from a window, or a small hole. So in general, the first evidence for Brownian motion is the random motion of dust or smoke particles in the air. Number two, random movement of tiny particles of graphite suspended in water. You can do it in your home, bring graphite and break it down, put a piece of graphite inside water, you will see these graphite particles move randomly. Here we have a new definition, diffusion, random movement of different particles so they get mixed up, or with diffusion for equal with gases. Examples of diffusion process, here when you put a color inside water, or this example, but put in your mind in the diffusion process for particles exist when particles move from area of high concentration to area of low concentration. From area of high concentration of area of low concentration. I think I finished slides of the first lesson. Yes, I finished the first lesson in the first topic in your syllabus, and I will continue after that, inshallah, the whole syllabus after that. Thank you.